Alright, so this then is the first stage of the problem. We've got to go through Moleville here and out the other side and then finally to the mass of oxygen. So this then, this amount right here, this moles of NO becomes a new starting amount for us. We're going to put that over 1. Okay. So that new starting amount goes over 1, and we need another conversion unit. And this time our conversion unit is going to be a molar ratio. And when you have to, for a molar ratio, what do you need? The coefficients in the balanced equation is where you get a molar ratio from. Not the mass, that's a molar mass calculation. We need the balanced equation here. And we need the coefficients in front of these two species here. Okay? So let me put it down here underneath. Since we want to match the units and species in the bottom of the conversion unit, or in this case the molar ratio, with the starting amount of whatever was remaining in the problem, we're going to use this coefficient here. And this is going to represent our 2 moles of NO. So we're going to put 2 moles of NO here. And since what we're trying to get to up here is oxygen, then I want to put the coefficient for the oxygen up here, and that moles and that species. Okay? So that's 1 mole of O2. Pretty simple, huh?
So, I have a question.
Ask away.
Okay, so if 2NO didn't have a 2 there, and if it was just a 1, would put 1 M
Yes.
mole in it?
Whatever the coefficients are in the balanced equation. So all that balancing equations in the last unit, we've got to be able to do that here. Okay? Alright, so now we can do the math. This number divided by 2 is all we got to do. 0.0833 divided by 2. Yes, somebody call my name. I've got to turn it on. It helps when I turn it on.
Why didn't you put 2 moles of NO2 on the top?
Because we're not trying to find NO2. Okay? The problem is asking for how many grams of oxygen are needed. See? So unless we're trying to find NO2, we don't use that. Okay? So in this case, we're trying to find this, and that's what we put on the top. Alright? And when I did the what?
You took that O2 just by itself in the first part, in the reaction? Yeah.
You lost me here.
That O2 right there, that's
Yeah.
what you use for the 1 mole?
Yes, there's an implied 1 right here. Okay? Remember, just like in algebra, if there's no 1 in front of an x, there's 1x, right?
So, and you use that 2 for the 2 NO right there?
Yes. That 2 right there is where we get that 2 for the 2 moles. Okay? Alright, so when I did the math, I get 0.04165. Now, these coefficients are counting numbers. These coefficients are counting numbers. We've counted, when we're doing all this balancing our equation, we're counting atoms, aren't we? Alright? So those are counting numbers. We don't use counting numbers when we're figuring out significant digits in a multiplication and division problem. So the only part of this problem that is used for figuring out significant digits is this one right here. That's got 3 digits, so I need 3 digits in this final answer. So to round that off, I need to round off that 5 at the end. Okay? Draw that arrow to show it's rounded off. And the answer I'm going to have for this stage is 0.0417 moles. Okay? Alright, so that's that stage of the problem. Okay? Alright, now, we're not done yet. Because look, I have moles of oxygen down here, don't I? Okay? But I've still got to get back to the, I got to get to the mass of oxygen. Okay, so what do we need to do to go from moles to mass?
Multiply.
You got to calculate the molar mass. Got to see what it says it right there. Look, it says molar mass. So we got to do the same kind of calculation, but in this case, we're trying to find the molar mass not for NO. We're trying to find the molar mass for O2. All right. So we need just 2 oxygens. 15.9994 added to itself, because we just need 2 of those. Okay. .9988, and there are no empty slots over here, Carolyn. Okay, so we don't have to round anything off here. And by definition, molar mass is the sum of all the atomic masses of all the atoms in the species, written in units of grams. And for us, we have to do what else with it? Yeah, we have to have the species. Something else. Equal to 1 mole of that same species. That's right. So there's an equality statement. Okay? So we got to take this amount here, and that's a new starting amount. We still got to get from here to here. Okay? So we got to put this over 1. And use this equality statement to build the conversion unit to find the answer. Okay? You can do that. I've already done a molar mass calculation for you up here. You can finish this. And here's a homework problem. Yes.
What is that?
Excess of oxygen. Okay.
What does excess mean?
You got more than you need.
So what you ask?
If we're starting with this, the amount of,
That's a whole new problem.
yeah, but we're still starting with this 250 grams of nitrogen oxide up here. Now you're going to calculate to the mass of NO2. So this is a second question based on this information. Okay? So you might want to make a note to yourself. There's 2.50 grams of nitrogen oxide. Okay? Make a note to yourself. That's what you're starting with. All right? Now, you need to finish this problem and then start on this one in the time remaining in class. Okay? This is now homework. Okay? No promises, but you got to plan on me taking this up tomorrow just like today. Okay?